Hi and welcome to another simple but very important part of chemistry, and we're looking at gases and solutions and something about Avagadro. Sometimes they mention that. Now it's about this bloke here, this Italian bloke, a little bit odd looking, Amedeo Avagadro. He's Italian. That's a bad accent, but there you go. I've put an avocado there because it sounds a bit like avocado. Anyway, he did some work about gases. So here I've put some particles because we know gas particles are far apart from each other. And he said in all his infinite wisdom that equal volumes of gases at the same temperature and pressure contain equal number of particles. So if I looked at 100 centimetre cubed of nitrogen, say, it would have 8 particles, for instance. It hasn't, but there you go. And if I looked at 100 centimetre cubed of oxygen, it too would have 8 particles. In fact, if I looked at 100 centimetre cubed of carbon dioxide, it would have 8 particles. Now, 8, I mean, just guessed at 8. It's not actually 8, but the point is it's all the same. He also said that 1 mole of gas, which is this many particles, this many, loads, right? That's 1 mole, all that, occupies 24 decimeters. That's 24 litres of space. That's the molar volume of a gas. Any gas. Yeah, any gas. So that means that 1 mole of sulfur dioxide takes up 24 litres of space. 1 mole of carbon dioxide takes up 24 litres of space. In fact, 1 mole of any gas takes up 24 litres of space. So the question that they'll give you, they're not about MRs and ARs and working out things. It's really simple. So if you look at this, how much room will 0.5 moles of oxygen take up? Well, 0.5 moles, so 1 mole will take up this, so therefore 0.5 moles will take up 12 decimeters. How about 3 moles of carbon dioxide? Well, that would be 3 times 24. 3 times 24. Does that take up 70? No, we don't want to do that. 72. I'll put it over. 72 decimeters. And then we've got this at room temperature and pressure. How many moles are in 6 decimeters of methane? So what we do there is go 6 divided by 24 equals 0.25 moles. So the answer would be, I'm going to do it again. It's just getting silly, 0.25 moles. So what we did there was say 6 divided by 24. Okay, fabulous. Now the next bit has got a lovely equation in it. Okay, another one to remember. And this is about concentration of solutions. If you're trying to work out moles, how much you need to put in some liquid to make a certain concentration, because in the lab you use strengths like 0.5 mole concentration, 0.1 mole concentration. Well, what does that actually mean? And how do you work it out? So concentration is measured in how many moles are dissolved in the total volume of 1 litre. So total volume of the substance is 1 litre. How many moles are in that litre? And the units for concentration are moles per litre. Nice. And here is the triangle that you need to remember. So moles over the concentration. Remember, the triangle means these are times and this is divide. So that's what you got to remember. MCV, I thought motor cars, motorbikes, cars and vans. I'm sure you could think of something much more interesting. All right, really simple. I've put a whole table down here. Let's put it up here. So I don't want to cover up my little mole. So here, if potassium iodide, if you've got 2 moles and you had 4 decimeters, so 4 litres, okay, what would the concentration of the potassium iodide be? Well, you do 2 divided by 4. So it would equal 0.5. Then again, the next one, sugar. So if I had that much sugar, 0.5, and I dissolved it in 0.25, what would the concentration be? There you go, 20. Okay, so that's 0.5 divided by 0.25. Let's just check that. 2. I was going to say, that did sound a bit dodgy there. Good job I checked it. Don't know what I'm talking about. Oh, pants. Okay, try and do the rest.